Hi students, welcome back. In this week's video, we're going to do sine and cosine of obtuse angles. And the questions are from assignment 6.1. Alright, so to explain how we can get the sine and cosines of an obtuse angles, I'm going to use the sine curve and the cosine curve to explain the concepts. So let's look at the sine curve first. Alright, so to get this sine curve, let's start off by having a unit circle. Alright, unit circle meaning that the radius of this circle is 1 unit. And let's imagine that you are the little point here, this point here called P, and you're going to travel along the circle, alright, to complete one round. So you're going to travel in an anti-clockwise direction, starting from 0 degrees here, and then to get 90 degrees. So from 0 to 90 is considered the first quadrant. And then you're going to continue to travel to complete from 0 to 90 and then 90 to 180. So from 90 to 180 is considered the second quadrant. And then you're going to continue to travel to the third quadrant, which is between 180 to 270. And finally, you travel back to the starting point by going through the fourth quadrant, which is between 270 to 360. So that completes one cycle. So a one cycle, it's comprises of 4 quadrants. Okay, so let's look at how the sine curve will looks like from 0 to 90. So from 0 to 90, this is how these, when the point travels, when this point P travel on these circles here, at different position, right? At a different position between 0 to 90, the curve will looks like this from here to 90. Okay, this is how it looks like. Right, what it's trying to say is that sine 0, okay, when you start from this point here, that is when your angle is 0 degree, right? So sine 0, if you use a calculator, you get sine 0, you will get 0. Sine 0 give you 0. So that explain this point here. Okay, and let's say if you go on to this point here will make an angle with the x-axis. Okay, right, so this angle could be 30 degrees, let's say sine 30, and it will gives you the ratio half. So sine 30 is half, which is this point here. Okay, and then it moves, let's say it keep moving on until to, let's say 90. So if you use a calculator, the ratio for sine 90 will be 1. So that explain 50, 60, 70, 80, 90. That explain this point here. Okay, and so it keep moving on. So if you observe it carefully, between 0 to 180, right, you will see that the sine ratio of any angles between 0 to 180, it's a positive value. So that explains this part of the curve here. You get a positive value. Okay, you can try, let's say sine 91 from a calculator. You will get a positive value, which is 0.99984. You can try sine 179. You get a positive value also, right? So that explains this part of the curve. However, when you go to the third and the fourth quadrants, you will realize that the sine ratio will be a negative value. Okay, it's a negative values already. Okay, you can just try pressing sine 200, let's say. You end up getting negative 0.342. Okay, so that explains this part of the curve. So for your E-math, for the elementary mathematics, we're just going to focus on the first and the second quadrant, meaning we're going to focus for angles between 0 and 180. Okay, so that's for sine curve. Huh? Right. So, but for cosine curve, it's a different story. Okay, for cosine curve is a different story. If you look at the cosine curve, cosine of any angle that is between 0 to 90. This one is between 0 to 90. This angle is between 0 to 90. Okay, you will see that the cosine of any angle between 0 to 90 will gives you a positive value that explains this part of the curve which is above the x-axis. That's why it's a positive value. However, between 90 to 180, okay, between 90 to 180, right, you will see that you actually get below the x-axis. In other words, cosine of any angle between 90 to 180, you can just try it out. Cosine 91, you get a negative value. Cosine 178, okay, you get a negative value. Okay, so the difference between the sine curve and the cosine curve is in the first two quadrants are between 0 to 180, right? Sine ratio of any angle between 0 to 180 will gives you a positive value. But for cosine, you only get the positive value between 0 to 180, to 0 to 90. But from 90 to 180, you get a negative value. Okay, right. All right, so we're not concerned with the third and the fourth quadrants. You will learn it in the additional mathematics. Okay, so what are the concepts involved here? Like what I've mentioned earlier on, we're just going to zoom into the first and the second quadrant, which is just between 0 to 180. So let's look at the sine curve first. So supposing I want to find the angle for y equals to 0.5. That means the ratio is 0.5. So what I'm saying is that I want to find the angle, okay, the values of x to give me 0.5. That means sine of the angle to get 0.5. So if you look at the diagrams I've just drawn, you will see that there are two particular angles. When I substitute into your sine x, you will get 0.5. The first angle is 90. Okay, you can just use your calculator to try. Press sine 30, you get 0.5. The second angle is 150. Try it. Press sine 150, you get half. Okay, so for sine curve, if you want to get ratio 0.5, there are two particular angles, that is 30 and 150. Okay, so but supposing if you don't draw the sine curve, then how are you going to get it? By solving it. So this is how we do it. When y is 0.5, that means if the ratio is 0.5, sine x is equal to 0.5. So we're going to find your first angle, which is the acute angle. So x is sine inverse O. Okay, right. Right, so sine inverse 0.5 is 30 degrees. So that is your acute angle. So it's possible to get the second angle, which is 150. So how do you get 150? That is when you take 180 minus 30. So 180 minus 30 will gives you 150. So that is the second angle that we have got. If you look at the diagram. Okay, so that's for sine curve. Huh? So now let's look at cosine curve. Cosine curve behaves very differently. All right, so if you look at the cosine curve, okay, if you draw the line y equals to 0.5, you see that there is only one angle. There's only one angle that will give you ratio 0.5. Yes, and that is 60 degrees. Okay, if you use a calculator, you press cosine 60, you get 0.5. Okay, right, which is a acute angle. So between 0 to 90, which is acute angle, the cosine of any angle between 0 and 90 will give you a positive value. Let's look at what happened if your y is negative 0.5. From the diagram, you can see that the angle is 120. Okay, so this is how we do it. When y is negative 0.5, you cosine inverse it. You'll see that you get 120, which is obtuse angle. So can you see the difference between the sine and the cosine? Okay, so for sine, that's summarized. For sine, if y is 0.5, you will see that it's possible to get two angles between 0 to 180. It's possible to have two angles, which is acute 30 and obtuse 150. However, for the cosine, is entirely different case. If y is 0.5, there's only one possible angle, that is acute 60 degrees. And if y is a negative 0.5, there is only one possible angle, which is obtuse angle, that is 120. Okay, so in summary, this is what we're talking about. For angle that's between 0 degrees to 180 degrees inclusive, referring to the first and the second quadrant, okay, sine x is equal to sine bracket 180 minus x. So what does that mean? So I'm going to give you an example. Okay, sine 30 degrees. The ratio for sine 30 degrees is half. Is equals to the ratio for sine 150. That is what it means. So for example, the ratio for sine 130 will be the same answer as sine 50. That's what it means. And the ratio for sine 127 is the same as sine 53. Okay, so that is for sine. So for cosine is a different story. That means cosine x is equal to negative cosine bracket 180 minus x. So what does it mean? For example, okay, the ratio for cosine 60 is half, right? However, the ratio for cosine 120 is negative half. So therefore, we are saying cosine 60 is equal to negative cosine 120. Cosine 60 is half. Cosine 120 is negative half. So I need to have a negative there, so that my negative times the negative half will give me back my half. So let's have another example. Cosine 20 degrees will be negative cosine 160, or cosine 140 is negative cosine 40. Okay, so you see that this angle add up to be 180. They're called supplementary angle. 140 plus 40 give you 180. 20 plus 160 gives you 180. 60 plus 120 gives you 180. Okay, so that's the difference between sine and cosine. Right, so let's put our knowledge into practice. Let's look at question 1. We're asked to express each of the following as a trigonometric ratio of the acute angle. Alright, so if you look at the angle that is given, 107, 1110, they are obtuse angles. Obtuse angles are angles that are more than 90 and less than 180. So these two angles are obtuse angles, and we need to write it as a ratio of an acute angle. Acute angle refers to angle that is between 0 to 90. Alright, so first thing first, let's write down what we have learned earlier on. Right, so we learned that sine x, the ratio for sine x is the same as the ratio for sine bracket 180 minus x. The ratio for cosine x is negative, okay, for negative cosine bracket 180 minus x. Okay, so if you look at cosine 107, what do you think is equals to? Yes, it's equals to negative cosine 73. How do you get 73? To get 73, you just take 180 minus 107. 180 minus 107 will give you 73. Okay, that's for cosine. Okay, you must have a negative there. How about for sine? Yes, sine 110 will be equals to sine 70. How do you get 70? You just practically take 180 minus 110, and that gives you 70 degrees. Okay, let's look at the possible O-level questions. Right, so if you're given a right angle triangle, so a right angle triangle will remind you of Picasso, will also remind you of Pythagoras theorem, right? So you're given a right angle triangle and you're asked to find part 1, part I is to find the values of x, and part 2 is to find the ratio for sine angle PRS and also for cosine angle PRS. Okay, let's do part 1 first. So for part I, we can just use Pythagoras theorem. Okay, so Pythagoras theorem is your a squared plus b squared equals to c squared. So we're going to substitute your a to be for the values of x and b to be 40. So that will be x squared plus 40 squared equals to 41 squared. And then from there, we can go on to find the values of x, which is 9 or negative 9. But since we are finding the length, x represent the length of PQ, it has to be the positive value. So we're going to reject negative 9. So that is part I. So for part 2, right, okay, we're asked to find the ratio for sine angle PRS. So if you look at PRS, it's an obtuse angle. Okay, PRS is an obtuse angle. And if you have to recall what we know about sine acute, the ratio for sine acute, the connections between the ratio for sine acute and sine obtuse. Yes, the ratio for sine PRS and obtuse angle is equals to the ratio for the sine acute PRQ. This one here that we've learned earlier. Okay, so the angle theta refers to your PRS, and then your 180 minus theta refers to this angle PRQ. Okay, so to find PRQ it's an acute angle, which is an angle inside a right angle triangle. So from there you can use right angle triangle, you can use Picasso, right? So to find sine, Picasso. Okay, so sine ratio, it's actually taking the value for the opposite sides over the hypo. So the opposite sides is 9 cm and the hypo is 41 cm. So the ratio for sine angle PRS is 9 over 41. Okay, let's look at part B. So for part B, if you were to recall, cosine theta is negative cosine bracket 180 minus theta. So therefore, your cosine of the obtuse angle is equals to negative cosine of your acute angle. Okay, and the ratio to find cosine of an acute angle is taking the adjacent side divided by the hypo. So the adjacent side is 40 cm and the hypo is 41. So it's negative 40 over 41. So this is how you do a typical O-level questions. Finding the sine and cosine ratio of obtuse angles. All right, let's look at another possible kind of O-level questions. Okay, you are told that this angle x is between 0 to 180, referring to the first and the second quadrant. All right, and you're asked, you're given the value for sine x to be 0.753, and you're supposed to find the possible angles of x. X represent the angle, so the possible angles that will gives you this ratio 0.753. Okay, so we all know that there are two possible angles, right? The two possible angles. If you have forgotten why there are two possible angles, please refer to the earlier slides. But I don't think your memory is so short lah, because it's just 10 minutes ago only that we have learned that. Okay, so for sine, it's possible to have two angles. One is acute. Okay, and the second one is obtuse angle. All right, so if you see that I have two answers here, one answer is expressed to 2 decimal places and one is expressed to 1 decimal place. Okay, because we will need one which is expressed in 2 decimal places for our next solution, for next working, because the next one we need to find the obtuse angle. So for better accuracy, for the intermediate answer, we should use the angle expressed in 2 decimal places. Okay, so the second possible answer will be 180 minus away for the 8.85, which give you 131.2 degrees. For final answer for angles, you should express the 1 decimal place. So therefore, the second possible angle to get ratio 0.753, it's 131.2 degrees. Okay, but for cosine, it's a different story. Yeah? For cosine, there's only one possible angle. One possible angle, which is the obtuse angle. And again, if you have forgotten why, please refer to the earlier slides. Alright, so this question is similar to the one we have done earlier on. Again, it's a very likely kind of O-level questions. Right, so in this case here, it's slightly different because you're given the grid lines, you're given the coordinate axis, x and y axis, okay? But it's not difficult. You can just still use that to find the length, okay, that you're supposed to find, except now that you have to come up with your own right angle triangle. Okay, because it's only in the right angle triangle that you can use your torcaso. So let's look at what we can find from the right angle triangle that we have just drawn. Okay, we're supposed to find the ratio for sine angle ABC, which is the obtuse angle. So we know that the ratio for sine angle ABC is equals to the ratio for sine acute angle ABD. And to find that is to get the opposite side over hypo. So your opposite side is AD, your hypo is AB. Alright, so to find AB, okay, here, this is 3 units. Okay, so AB is 3 units. BD will be 4 units. You can count it 1, 2, 3, 4. 4 units. So to find AB, we can use Pythagoras theorem. Okay, AB squared, which is your C squared, equals to A squared plus B squared. So which is equals to 25 for AB squared. So AB is just the positive values, 5 units, because length represent positive values. Actually, to be more accurate, you should say AB is equals to -5, but we're going to reject this one. All right, so AB is 5 units. Then we can substitute into here 5, and then AD we found to be 3 units. So therefore, the ratio for sine angle ABC is 3/5. So how about the ratio for cosine angle ABC? Yes, so the ratio for cosine angle ABC is negative of cosine ABD. And to find the ratio for that, it's adjacent over hypo, which is BD over AB, which is -4/5. Okay, I think we need to put the negative here. Okay, I think just bracket it. Yeah, to be more accurate, yes. Should bracket it, bracket negative adjacent over hypo, yes. Okay. All right, let's look at 11 part 2. So 11 part 2 is an open questions, meaning that there is no one fixed answer for the coordinates of point D. All right, there's no one fixed answer. So what we are saying in this question is there is a particular line, a horizontal line, y equals to 1. And on this line, y equals to 1, there is a point D such that the cosine of this angle ADB, it's a negative value. Okay, right. So what sort of angle ADB must be? What sort of angle ADB must be such that the cosine ratio of this angle is a negative? Right. So your angle ADB has to be an obtuse angle. Yes. So for cosine angle ADB to be negative, the angle ADB needs to be an obtuse angle. Alright, so let's look at this line y equals to 1, which has already been drawn on the diagram. So let's indicate some possible positions of point D. Right, so D could be here. It could be here. Okay, or here. Right, but whatever position that you choose for your point D, it definitely has to be an obtuse angle for ADB, which is what we have agreed on earlier, right? So if you let's look at point D1, the positions for point D1. If you're going to draw a line joining from A to D1, oh, okay, that's not all right. You'll see that this angle here, AD1B, surely is an acute angle. It is not obtuse. So we need to eliminate this point here. So point D1, it's not the point that will give us an obtuse angle. So you go on to look at point D2, okay, that will not be an obtuse. D3 also. However, if you look at point D4, you see that AD4B, this angle clearly is an obtuse angle. So D4 is one possible position. How about D5? Yes, it's also one possible position. Oh, that is D5. Okay, D6. Yes. D7. No, D7 will not give you an obtuse angle. In fact, AD7B will be a 90 degrees. So we need to eliminate D7. So therefore, the possible positions for point D can be D4, which is the x coordinate for D4 is 1, y coordinate is 1, or D5, which is 0, 1, or D6, which is -1, 1. Okay, so any one of this answer will be correct for 11 part 2. All right, let's look at another possible kind of questions. It is actually not difficult at all. They just want to, the questions is confusing in the sense that, you see, so far what I've been dealing of is like given sine A equals to something or cosine A equals to something, right? So what the questions is trying to trick you is instead of just giving you a variable A or B, that gives you a combinations like x plus 10, x minus 10, or sometimes it could be like 2x minus 20 or 3x plus 10, the kind of thing. But the concepts involved is the same as what we have done earlier on by solving sine A equals to something or cosine A equals to something. Okay, what do I mean by saying that? Yes, so first of all, you must remember what we have learned earlier on. That is the ratio for your sine acute is the same as ratio for your sine obtuse between 0 to 180. Okay, so we're just going to replace the x plus 10 with the letter A. There's something that we are familiar with. Yeah, this is the one that I've just explained, that the angle x can be acute or obtuse. And I'm just going to replace your angle A with x plus 10. And you see that A is something that we're familiar with, right? Sine A equals to 0.47. So how do you go about finding the possible values of A? Yes, you just sine inverse it, right? So we get the acute angle, which is 28.03. We understand that there is also another possible angle, which is the obtuse angle. Okay, which is 151.97. But however, your angle A is just a substituted value for x plus 10. The real values you need to find is x, not A. So I need to substitute back my A into your x plus 10. Okay, so x plus 10 is equals to 28.03. So my answer for your first value for x is 18.0. The second one is when your A is 151.97, x will be 151.97 minus 10 gives you 141.97. You're supposed to express your answer to one decimal place. Okay, so you will carry it 9, carry 1 to your 1, become 142. But you need to put the 0.0 because you need to express the one decimal place. Okay, so this is how you do it for part A. So we're going to use the same method to do part B. Okay, so for cosine, right, it's a different story. Cosine x is equals to negative cosine 180 minus x. So therefore, your cosine, your angle x, okay, your angle x can only be acute if the ratio is positive, or only obtuse if the ratio is negative. Okay, so we're going to use the same method as what we've done earlier. We're going to just replace your x minus 10 degrees with the letter A. All right, and so you get a negative ratio. So therefore, your angle A has to be an obtuse angle. Okay, one angle only. Now we're going to replace your angle A with 124.06 into this to find the values of x. So therefore, x is 134.1 degrees. Okay, right. So in summary, if your angle is between 0 to 180, that means between the first and the second quadrants, the ratio for sine acute is the same as ratio for sine obtuse. Right. So if you're doing something like part A, there are two possible answers for x, one acute and one obtuse. But for cosine, it's different. Okay, cosine is different. For cosine, if you have the ratio for cosine x is a positive, then x is the acute angle only. If the ratio you get is a negative one for cosine, then the angle is an obtuse angle only. Okay, so for cosine, it can only be acute or obtuse. For sine, it can be acute, also an obtuse. All right. Please look through again. Okay, you really have to work it out with me, try out the questions on the own, and even if possible, try even more questions on your own from the textbook or from the assessment book or from other sources to practice applying the concepts we have just learned.